from the College by the Lake, Coeur d'Alene, Idaho. Local, regional, national, and international guests discussing the issues and topics affecting the way you live are on Forum, the North Idaho College Public Forum, with your host and moderator, political scientist Tony Stewart.
Last week we brought you a very interesting, I thought, and exciting program about the solar system and exploring the planets of the solar system. And we promised you at that time we would return this week with a even broader issue, and that is the whole question about how the universe was formed and what it might be about. And that's really a mind-boggling question, and also even some theories that there may be black holes into an expanded universe or plural universes. And we're happy to have back our same two guests from last week, our colleagues at North Idaho College, both of them coming to us from the Division of Natural Sciences. And first of all, I welcome Kurt Nelson, who holds a BA degree in mathematics from the University of Washington, Seattle, and he has an MS degree in physics from the University of Idaho. Kurt, welcome back. It was really exciting last week. And next to him is our colleague Lloyd Marsh, who teaches again at North Idaho College. He holds a BS degree in the field of chemistry from the University of Idaho, and his master's degree is in electrical engineering, and it's from the United States Naval Postgraduate School. Lloyd, you've been here before, and it's always a pleasure to have you on the program.
Thank you.
And as always, I'm pleased to have Steve Schenck, our regular panelist, and Steve Schenck is the Dean of College Relations and Development at North Idaho College, and we're going to again start off a little different this week with you, Kurt. You have brought with you a couple of slides about the universe, and we're going to have you to describe these two for us. And in fact, the first one has to do with the Hubble telescope and looking at a portion of the universe. And then the second slide has to do with the Big Bang Theory. And so as we get into these two slides, I would ask you to tell us how it all began.
Certainly. First slide shows on the left, you'll see a photograph or a picture of an optical picture of a piece of the universe or a piece of the sky. And what it is an elliptical galaxy, a kind of a cigar-shaped looking collection of stars. And that was the best that we could come up with before Hubble. If you see the expanded view on the right, you'll notice that there's a lot of detail, little blue dots, a globular cluster, and you'll find out that the Hubble Space Telescope has been a wonderful engineering achievement, both in the line of technological achievement and actually upgrading and correcting the mechanisms that we needed to look at space at a farther distance away.
Yeah, it tells us more.
The whole idea of the Hubble telescope was to look beyond what was possible to look at from the Earth. And when we look from the Earth at space, we have to look with optical telescopes for light. We have other kinds of telescopes, radio telescopes, ultraviolet telescopes, gamma ray telescopes, you name it. And the Hubble was supposed to give us about 7 times further into space, which would be about a volume of 350 times roughly. We're looking for the outer edge, if we could ever get to it, trying to determine the size of the expanse of the universe and if there's anything different out there. And what a marvelous thing it has been, the Hubble Space Telescope. Just last summer we have the first image, I saw it, from the Hubble of a solar system in space. Recall that when you have a planet, the planet doesn't glow on its own accord, and so you only have reflected light from the planet to be able to see it. And to detect a solar system, quote, solar system, we don't know what kind yet, but we know that there is one through the aid of the Hubble Space Telescope.
Oh, new discoveries. Now the next slide has to do with the Big Bang Theory.
Yes, the Big Bang Theory is has been fairly well received up to about 1930, when we had telescopes of larger quality. We found through Hubble's work that we were in a galaxy and there were other galaxies. And so the idea of the universe as being a larger place than we had thought originally came into being. Then you had to argue in the 1950s about whether the universe was static, whether it's continuously always the same, or whether it's going to change. Then you had the other people thinking that maybe it's dynamic, it moves, and it has a direction. And if it does have a direction, then Hubble's constant, which was the slope of a line on a graph, Hubble's constant probably could be worked backwards. It would be like an explosion of gas, and you watch it explode, and you keep track of it. I like to use the analogy of raisins in a loaf of bread, and you have to think like a raisin. And as the bread heats up and expands, you look at your neighbor raisins and you find out they're all going away from you. And if you can imagine that picture of the expansion of the universe, we got the idea that maybe the universe was originally a big bang, like raisins exploding or going outward. And if it does go out, how old have we been doing this? How long in time have we been doing this? And where are we going? And so the Big Bang Theory kind of showed up, being all of the mass or matter at the universe was at a point, and all of a sudden one day it blew up and expanded, and we kept going and going and going. And as the stuff expands, called gases and mass, etc., the universe cools off. And one of the breakthroughs in the late 1970s was measuring the temperature of the universe. It happened with the theory and also experimental work that it was 3 degrees, roughly 3 degrees Kelvin or above absolute zero. So that offered a lot of credibility to the Big Bang Theory. When you read recent articles less than a year old, since the last 15 years of the theory of quantum mechanics expanded, we have found that it isn't really such a nice theory after all. Here's another time in history where complacency and arrogance, we shouldn't get that way, where if we are arrogant or complacent about our theories, we kind of stale out. So another breakthrough about the idea that maybe there's more than Big Bang, maybe it's inflationary or expands at an ever-increasing rate, and maybe there's a multiplicity of universes. It's very comforting to know that the universe, if it was expanding, could it ever come back? And if it could come back, what do you need to make it come back? And of course, in the last 30, 40, 50 years, to make the universe come back and oscillate so it'll be infinite in time, you need something. You need more mass. And so we went looking around for neutrinos out of the sun, trying to find the missing mass in the universe. And as of just a few years ago, or in the last few months, it was proposed by a lady that there's probably dust and dirt out there called dark matter. And maybe it's the dark matter we're looking at and cannot see that will complete the cycle of the universe and make it come back on its own again. And so what do you see when you stand out there and look at the universe? You see with your eyes about maybe 10% of what's there. The other 90%, my wife would tell you, that is just dust in the house. And so we're really looking for a search, a quest for why are we here, where are we going to the universe, and how does it work and how does it operate? And that leads us back into studying the subatomic nature of particles, the particle theorists. They're the people that had the brainchild about the Big Bang theories and what was there at the beginning of the universe. And the particle physicists have a real strong play into the future development of theories about the universe.
Steve Sheen.
I've got to follow up on a couple of those,
Okay,
those
sure.
things, because I'm a little bit lost, and Lloyd or Kurt, whomever, jump in. You mentioned that when you look outside, and I was trying to think of some way to put this all into perspective, and I guess at some point I'm going to ask somebody to give us a good, solid working definition of solar system, galaxy, and universe. But you say you only see roughly 10%. Now, you didn't mean by that the stars that are visible to the naked eye at night when we stand outside and look up in the air are roughly 10% of all the stars that are out there?
Well, all the matter.
Yeah, why don't you answer that, Lloyd?
Yeah, well, all the matter. We can only see what's in the visible light spectrum. And if it doesn't radiate in that spectrum, we can't see it. And to explain a theory that would have enough mass in order to slow down, because we know that matter has an inherent gravitational attraction for other matter. It's just inherent. And if you're going to have enough mass to slow down the expansion of the universe and begin a collapse back to maybe an oscillating universe where we would go back through another cycle, perhaps, of the Big Bang, that can only be explained if there is enough matter out there to do it. Well, mathematically, that supports the contention that we only can see 10% of the matter, because there has to be more matter, and if we can't see it, what do we call it? Matter X, or dark matter. And so it's non-radiating matter that we can't find.
Okay. Now, let me put that in a different perspective. I'm standing outside on a clear summer night away from artificial light sources, so I can see thousands and thousands and thousands of stars. Mm-hmm. What I'm really seeing, and we've got our planet, one of 9 planets that revolve around one star, that is one star in an incredible number of stars in our galaxy. And you described, I think, Kurt, last week, that it was like a big pancake out there if you could get a cross-sectional view of it. The naked eye sees only a tiny fraction of the stars that are even in our galaxy. Is that correct?
That's correct, Steve. The human eye can only see roughly what we call 5 magnitudes of stars. And with the expansion of the telescope, you can see down to 28 magnitudes, or 24. What it means is you can expand it many, 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 many times if you have binoculars or telescopes. And when you do that, when you look at space, even with a simple set of binoculars, a 7-power set of binoculars, I have students sometimes say, how many more stars can you see with binoculars than without? And it's just incredibly different. So when you look out into space, you see little fuzzy spots, and you see little collections of stars, and you try to measure the distances to them, which we have done successfully for some globular clusters and galaxies. And pretty soon you find out there's millions of galaxies. And we can hardly even imagine how many stars there are in one galaxy, and now we're talking about millions of galaxies.
Well, let me stop you right there and ask you to define, how do we decide that this is where one galaxy stops, and here's where another one starts? Is it just relative positioning to one another?
The expanse of space is so large that there's a break between one galaxy and another. And there's a void between all of these. Sometimes you have an individual star, rarely, even lots of binary star systems revolving around each other. Most of them are binary or above, tertiary systems. And you have groups of stars, and you have clouds of dust even floating around. And there is a definite break between those. Now, we're looking from a point out into space all over the place. It would be like sitting in the inside of a dandelion after the fluff shows up, and you're looking outward, and you're looking radially out one of those fluff balls. And we have just a piece of it we're looking at. And it's so full of life and so full of things, such as formations of different types of stars, those kinds of stars. We have been studying the different kinds of stars that have developed. Stars are born. I don't know if we knew that or not. It could be that that's a recent theory. Stars have a life cycle. They're born. They live through their average life. They die. They have a violent death, kind of, and become one of 3 things. They can become a neutron star, they can become a dwarf star and be very small, or they could become a black hole. And there goes another a couple books that you could read up on these things. Stars live a life and have an existence and die. And it's a wonderful story about the types of stars we look at. Now, one star is kind of famous. I have a favorite one. It's called Arcturus. It's a red giant. It's very large, reddish color, and it's in our northern hemisphere. And I was told when I read some history books about Hawaii that the king had a vision, and he set sail, and he's supposed to follow this red star and establish a colony. And that star was Arcturus.
Now you just opened up a whole group of other questions I could ask, but I got one more that I'm confused about that I'm going to get through, and before I go back to Tony, he can follow up on some of the latest ones. And Lloyd, I'm going to ask you to answer this one. Kurt mentioned the possibility of more than one universe. Well, now that blows my rudimentary concept of what I thought I understood. I think in terms of this planet and this solar system, the planets that revolve around our sun, and that belongs to a galaxy where there are millions of stars and there are millions of galaxies. But I just assumed that the universe was everything. There was only one of those. We haven't even found the furthest reaches of it, and it included every planetary and solar body that's out there. But now you say there may be more than one of them.
Well, I think we have to go back to some very basic things like definition of the universe. I mean, is the universe everything we could imagine, or is it only what we think we can see? It's hard to imagine. I mean, if you take that definition as being a broader one, and now we're really pushing the edge of the envelope. I mean, we're talking about theories that Tony mentioned, black holes and wormholes. Now they use the term wormhole to another universe. I mean, maybe that is an access hole to another great universe. And we're pushing theories so hard right now in answering those questions that to give you a definitive answer would be misleading. The possibility exists that there are other universes that could duplicate ours, and that maybe somehow they're related or connected so that this matter-energy transfer could take place. But, I just can't be definitive there. I'm sorry.
It's kind of
Well, at least
strange.
I'm not alone in my confusion.
Yeah, right.
It's strange, Lloyd, while you mentioned the other universes and possibilities, isn't it also strange that we're also looking at a polarized view of what are the basic building blocks of the universe, and what was it that actually was here when the universe started. And now we're back to the last few years since the 1970s of the quark theory, the search for the last quark, and we found those within the last year. And a lot of people don't know it. They walk down the street and they don't realize that we're looking for mass and we're looking for the last quark, and we have found that through our machinery and closure to the universe.
We know that when you broadcast programs such as this, that the great majority goes vertically out into space and a small percentage horizontal to the planet. So our program's 23 light years out in space, and maybe this program someday will reach life somewhere, and maybe they will answer some of your questions.
Hopefully so.
Also, in all seriousness, my first question on this round has to do with the age of the universe, and Kurt, we'll start with you. When you talked about some of the theories and possibilities, such as the Big Bang, what are some of the best estimates?
Well, some of the best estimates have been anywhere from, since my lifetime being very short, has been 18 billion years down to around 12. And you don't want to get too upset whether it's a 12 or an 18. The idea is it's above 10. And billion is also a large number, and you try to pin that down, and we're talking about one universe that had one Big Bang, and we have occurred through all those years, and the galaxy has been formed, and etc.
And some of the galaxies are much younger than the universe.
Some galaxies are younger than the
expanded.
universe. You have galaxies being born as well as stars.
Yes.
You would hate to think that all of a sudden no stars would be generated and no more life in the future of the universe, and wouldn't that be strange? So there's always new things, new mechanisms establishing themselves.
Based upon that figures about the universe, about how old is the Milky Way galaxy?
Well, the Milky Way galaxy, I don't recall what the age is, but it's younger than the universe. That makes obvious sense.
And the solar
we also
system
know our
younger
sun is what, Lloyd? 10 billion years?
About 10 billion
So
years
somewhere
old.
between 10 billion and 10 million is the age of the galaxy. And it doesn't bother me how old it might be. And what's more puzzling is in the galaxy, in the center of it, if we could see the center, what drives this thing? We say, theoretically, a black hole, whatever that might be.
Now you've really got me going, because I have that kind of mind. It's always wondering. When I was a little boy, I got in lots of trouble because I was always questioning so much. But when you talk about the universe being a certain age, I have a two-part question for Lloyd. First of all, before the universe was formed, something was there. I mean, is it? I mean, it can't space or something. I mean, it can't be void of nothing, could it?
Well, I think we have to talk about maybe looking back in time, and I would use this in this relationship. If the sun burned out, it would be 8 minutes later, we would know that. And so we're looking at the sun 8 minutes ago. When you step outside the door and you see this object in the sky, you're looking at this 8 minutes ago in time, as we know it. And time is just some sort of sequence of events that we put together. Well, now when we go up with the Hubble and we look back 12 billion years, we're looking out into space 12 billion light years. So we're looking at events that occurred 12 billion years ago. And so now we're trying to trace it back. If we talked about the universe being 14 or 18 billion years old, if we can look out far enough, theoretically, we can look back to the beginning of time if you start the clock running at the Big Bang. And so that's what we're looking. We're looking to see what was there, if there was anything. I mean, it's hard to believe. And now I think you're starting to tread on the edge of maybe somebody's religious convictions or certainly theories that are going to be very, very difficult to arrive at the solution, because it's against our nature to think that there was a time when nothing existed. I mean, what is nothing? Mm-hmm. And so I guess in our quest for that, we just keep looking further and further back and evidence. And as Kurt says, we've taken the temperature of the universe and we're looking for fossils, just as some archaeologist on Earth goes out and looks for fossils back in time to understand that. We're looking for fossils of the universe and more ways to figure out what's happening. Kurt, can you add anything?
Yeah, speaking of nothing, I'm going to add some more. The tools that the astronomers and the physics people have used on the Earth have been giant atom-smashing kind of machines. And to look for these 6 quarks, the subatomic particles that compose the electron and the proton and all those, it was theorized that the beginning of the universe had quarks running around in it, and there were no protons, which is part of your human body. And they evolved very quickly, and so protons have survived. Now we have run out of not money, but technology to build machines large enough and hot enough to be able to study it in further detail. So now we're back in a full circle, back to the human mind. We're back to thinking and the philosophy. And so we're finding philosophy and the study, the questions that we still ask, have to be now really tackled in a different light. And we're finding physics people and astronomy people and philosophers starting to merge together again, come up with theories and explain why we're here, and to expand, because we're out of machinery. The superconducting supercollider project in Texas that folded up was an attempt to measure the last quark. A lot of people don't know that that's what it was for, and we think we have found it with other laboratories. But to think about the future and beyond and other models of the universe is going to require young people, people with questions like Tony has, that don't take no for an answer, and people who search our libraries and look at books and read about the latest pictures of the solar system or the universe, and ask those kinds of questions. These are the people we need. And that's why Lloyd and I are here in the education business, to try to promote people to think very hard, whether they're philosophical convictions or whether they're science models of the space or the universe. That's our challenge. And right now, we're a little bit under quandary as to what to do next.
Well, we have one more question
Yes.
to try it on, and then we'll go back to Steve. As you've indicated on the program, the universe is expanding.
Yes.
It has to expand into something, and so it expands into some void. And if that can happen, could we possibly assume that it's endless, the void? That there is no
Philosophically,
end?
Yes.
philosophically, yes.
Yes, we could.
That is hard mentally to
Yes,
comprehend,
it
is it not?
Yes, it
Yeah,
is.
very, very difficult.
Then if it can do that, and again, I'm back to the black holes,
Okay.
are tunnels
Uh-huh.
that might go in through the void into another universe that might be even larger than this universe?
That's a pretty good analogy, Tony. The idea that when you turn on the faucet in a bathtub, the water comes out of it. And when you pull the plug on the bathtub, the water goes down. And when the water enters the bathtub, it's called a source. And when it leaves the bathtub, it's called a sink. And so we can think of the universe as being places where matter or energy emanates out of the source. We can also think maybe there's places where things will sink and go back in. Now, there's always water around, we know that, collectively, that there's going to be a source and there's also a sink. But it has to be both in parallel or in tandem ideas.
Steve Shink.
Well, there's so much here that confuses me that I might as well jump to one of the difficult concepts to understand. And earlier, Lloyd Kurt mentioned that when stars live out their life cycle, they become either neutron stars, dwarf stars, or black holes.
Mm-hmm.
Could you tell us a little bit about each of those? And I guess the one
Yeah.
that is most fascinating is the concept of the black hole. The others you can, I mean, just the idea of a star burning out, you expect to see something left, some residual, lower
ember.
power, cinder
Right.
kind of a thing. But now this black hole idea is hard to grasp.
Well, it's a wonderful thing that we have this vast laboratory out there. We can look into the sky, and we've got all sorts of stages of the life. So we can study stars' life in various stages, and this allows us to know a lot more than we would if it weren't. I guess the answer to the question is, how much accumulated mass do we start with? When you start with, let's say, one solar mass, which is our sun, the death throes would be a red giant, and then so forth, and a dwarf star of some sort. And then when you accumulate more matter to begin with, the lifespan is shorter because the energy depletion is faster. And we get to the ultimate when I have many, many solar masses that accumulate and a star is born from that collapsing matter. Then we go through a stage called a supernova, and we splatter that matter out, and the collapsing matter that's left forms a black hole, which we believe is sort of ultimate density. I mean, you've got ultimate gravitational attraction, and so everything. In fact, the density is so great. Why we call them black holes is that light does not have enough energy to get out. And so, as we take ourselves through these three major breakdowns in what is the result of a star's life, you look at that, and that's what we come up with.
So a black hole, did I follow this correctly? A black hole isn't just one collapsed star, it's many collapsed stars?
It's one star.
One star,
large,
but
one
a
large
very, very large, many solar masses, if we compare it to our own sun, that have collapsed now on itself and created, because of the gravitational attraction, this very, very compact thing, which has the ultimate density. When they talk about a neutron star, the density of a neutron star is such that a teaspoonful of a neutron star of matter would weigh or have the same mass as Mount Everest, for example. That's sort of beyond our imagination, but can you imagine now, even beyond a neutron star, is a black hole?
Now, is this an evolutionary process? Each star will go through those different stages, or is it a function of the kind of star you start with in the first place, as to whether it'll turn into a neutron star, dwarf star?
It's very interesting. A star's death is determined by its mass when it's born. And this theory is worked out by Chandrasekhar, an Indian astrophysicist. His theories have been very well received. And the size of the material when you're born dictates your end. Now, that isn't true for a lot of things in nature, but it's very predictive for stars. And if you have a real large mass, as Lloyd mentioned, you collapse gravitationally, and even light cannot emanate out of a black hole. A neutron star is extremely difficult to imagine. It would be like the Niels Bohr atom model, where you have a nucleus and then you have electrons whizzing around that. You stripped all the electrons away and then just pushed nuclear matter together, that would be what composes a neutron star. And when it collapses, it spins, and when it spins, it goes around like a lighthouse beacon. And as it goes around and spins and spins and spins, the light comes by your face and goes swish, 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 and those are called pulsating stars.
On that note, we have to bring the permanent conclusion. I have a signal that we're out of time. On behalf of Steve Schenck and our staff, we thank you both for a really intriguing 2 weeks. And I guess we certainly can conclude the program by saying that our sun and our Earth and our solar system is temporary, that it will come to an end.
And unique.
And unique.
As we know.
Well, on that note, we will finish this program with a lot of humility, and we thank both of you for being here. Ladies and gentlemen, we brought you a 2-week series on, first of all, the solar system, and this week on the universe. I hope you found it as intriguing as Steve Schenck and I have, and I'd like to invite you to be with us again next week at this same time, when we will discuss yet another issue that we believe that will be of interest to you. Until then, please have a good week. I am Tony Stewart.
The North Idaho College Public Forum was videotaped live from the studios of Instructional Technology on the campus of North Idaho College for viewing at this more appropriate time. We invite you to join us again next week for another all-new edition of the North Idaho College Public Forum on this public television station.